Hello Math 130 students, we are going to pick up on page 27. We are going to solve for amounts other than a new balance with a compound or continuously compound interest. And we usually are going to be solving these type of problems with this formula in mind, where A is going to be your final amount, P is equal to your principal amount, so that's the initial value. We have our R, which is going to be our rate. And of course we have our T, which is going to equal our time as well. So for the first example, Davis decides to think about retirement and invest at the age of 30. He invests $5,000 and hopes the investment will be worth $250,000 by the time he turns 70. If the interest compounds continuously, approximate what rate of growth will he need to achieve this goal? Round to the nearest tenth of a percent. So you already know the formula that you're going to be using. You know you're going to be using A is equal to P times E to the R times T. So if I am looking at this first number, which they say he invests $5,000, well, that's your initial value. So that's going to be your principal amount is going to be your $5,000. So here you're going to have that P, principal amount, is equal to $5,000. Then it specifically says that they want the final amount to be worth $250,000. So that's going to be your A. So your A value here is $250,000. And the next thing we need to figure out is time, okay? So if I'm thinking about time, well, they give us two ages. You're going to start the investment at 30. So when you're 30 years old, this is when you're going to start investing. He hopes that when the age of 70 comes, that you would have this much into the account. So what we're going to do is we're going to do subtraction. So 70 minus 30 is going to give us 40. So here my time is going to equal 240. So the rate, approximate the rate, right? So this is what we're trying to find. So R is going to be our unknown. This is what we're trying to solve for. We're trying to solve for a rate, okay? So I know that I have A is equal to my principal times E to the R times T. So my A amount, I have 250,000 is equal to the P, which is the principal amount, so that's 5,000. And I have times E, and that R value is what I'm trying to figure out, I don't know, and that T for time, we said was 40. So what I'm going to do here is I'm going to divide both sides by 5,000. So then I really just have 250 divided by 5 is equal to E to the 40 times R, okay? And so when you do this in your calculator, 250 divided by 5, that gives you 50. So in this case, what you want to do is log both sides, or actually since it's E, natural logs both sides. So natural log of 50 is equal to the natural log of E to the 40 times R. So we know that we are going to have natural log of 50 is equal to, and the L and E cancel, so you have 40 times R. So you divide both sides here by 40. So now you have that the natural log of 50 divided by 40 is equal to my rate. So you can just plug that into your calculator. So ln 50 divided by 40, and that gives you a 0.09 7800575 is equal to my R. And I plugged that into my calculator. And remember, it specifically said to round to the nearest tenth of a percent. So first, I need to change it into a percent. So percent. So that means move the decimal 2 places, 1, 2. So now I have a 9.78000575% as my rate. But since it said to round to the nearest tenth, that would be here. So that tells my 8 to bump it up. Now I would have a 9.8%. So that is the rate that I would need it to be in order to grow that $5,000 into $250,000. So now let's talk about Jasmine. She's going to invest $4,000 in an account that compounds interest continuously and earns 5.5%. How long will it take for her money to reach $80,000? Round to the nearest tenth of a year. So again, I have my A is equal to my principal times E, R times T. So your principal, your investment amount is here, it's listed. So I'm going to have my principal amount as $4,000. And it already gave me my rate. My rate is 5.5%, which translates into 0.55. And then you have what you want as your final amount. You want it to reach 80,000. So I'm going to have that A is equal to my 80,000. So how long? So that's going to be for my time. So T here is unknown. That is what you're trying to figure out. So if I have A is equal to P times E to the RT, now I'm going to plug in my variables. So for my A amount, I have 80,000. For my principal, I have 4,000. It's being multiplied by E to the R value, that's 0.055, and I have my T, which is unknown. So here I divide both sides by 4,000. So when I do that, I can always cancel out my zeros. So I really have 80 divided by 4 is equal to E to the 0.055 T. And 80 divided by 4 is 20. Since I have E, to solve for that, I'm going to have to ln both sides. So that the ln and E cancel, so I'm left with a natural log of 20 is equal to a 0.055 T. So now I'm going to divide by 0.055. So now I have the natural log of 20 divided by 0.055 is equal to my T value. Now I'm going to go ahead and plug that into my calculator. And I'm going to get that this is 54.46785. And I have to remember that it specifically said to round to the nearest tenth of a year. So the nearest tenth is 1 decimal. So that 6 tells you to bump it up. So you have a 54.5 years. Okay. Now, we are going to have a different formula. So we're going to use this formula when we use the exponential growth and decay models to find the values other than the resultant value. So for example, number 1, it says this radioactive element is often used in diagnostic medicine because it is relatively because it has a relatively short half-life but lasts long enough to get the needed testing done on the patient. If its half-life is 6 hours, how much of the radioactive material from a 2.5 milliliter injection will be in the body in 30 hours? Round your answer to the nearest hundredth. So using our formula that we know that we're going to be using, which is A is equal to A naught times E to the KT. So here our variables are slightly different. What's different here is K. You can think of that as your rate, but for now we're going to be thinking of that as our growth decay. Or better yet, let's think of that as our decay constant. That's a better word to describe it, decay constant. So we still have our A naught, which is our initial amount. We refer to that as the principal amount when we're talking about money. And A is still going to be your final amount that you have. So when we read this, it says that, let's see, if its half-life is 6 hours, so that's going to be my T value. So T is going to be my 6 hours. And your initial amount that you have, let's see, how much of the radioactive material from my 2.5 ml injection will be in the body in 30 hours. So here, that's going to be your A naught, which is a 2.5. And your final amount is what you're trying to figure out. What is going to be your final amount? But there's something particular that they gave us. They gave us that the half-life is 6 hours. So let's think about this for just a second. So if I start with your initial amount, right, which is a 2.5, right? So then in 6 hours, we are going to have half of that. So 1/2 times 2.5 is going to give us a 1.25 according to this half-life. So we know that when the T for time is equal to 6, your A amount is equal to 1.25. And we're going to go ahead and use that piece of information. So we know that A is equal to 1.25. So now when we're plugging things in, I know that A is equal to my A naught times E to the K times T. So we have our A value. Our A value is that 1.25 since it was the half-life. We have our initial value, our A naught, which is the value we started with, and that was the 2.5. It's getting multiplied by E. K is unknown. So this really is the unknown that I do not have right now. So I'm going to call that K. And here, since we're talking about half the life, our 1/2 is going to be equal to our T value. Or sorry, it's half-life of 6 hours, so our T is equal to 6, as mentioned before. Okay. So now from here, what I'm going to do is I'm going to divide by 2.5 on both sides. So 1.25 divided by 2.5, and that's going to give me a 0.5. So 0.5 is equal to E to the 6K. So now I natural log both sides. So that ln and E cancel out. So you're left with the natural log of 0.5 is equal to a 6K. So I'm going to divide by 6 on each side. So I can get that the natural log of 0.5 divided by 6 is equal to my K value. And it says that I want to round to the nearest hundredth. So I definitely want to get my fraction from my calculator. So up in the numerator, it's natural log of a 0.5, and down below I have 6. So that decimal approximation is going to be negative 0.11552453 is equal to my k. And since it said to round to the nearest hundredth, well, 1/100th is here, so that 5 tells you to go ahead and bump that up. So it would be negative 0.12 is equal to my k. So that's just half of the problem. I just found the unknown, okay? They want to specifically understand what's going to happen in the body in 30 hours. So here's like, okay, well, in 30 hours, I can tell you, since now I have all of my information. So because I'm talking about a new time, my time here is going to be 30. Your initial amount is never going to change. Whatever you started with, that's always going to be true, no matter if you go 6 hours or 30 hours, okay? And so our k, which we found, is always going to be fixed as well. So it's decaying at the body of a negative 0.12, okay? Since it's our, what did we call it? Our decay constant. And so the final amount is what we don't know. I don't know how much of this is going to be in my body given these parameters. So I know that A is equal to my A naught times E to the K times T. So the final amount, I don't know what that is, but I know the initial amount didn't change. It's still 2.5, and I still have E. And the K value that I'm now plugging in is at negative 0.12. That's what I found in the first part. And I have my T for time, and now that new time is going to be 30. So I can just plug all of this into my calculator. So I have a 2.5 being multiplied by E to the negative 0.12 times 30. And that is going to give me that A is equal to a 0.068309306. So this is how much is going to be left in your body. And since we're rounding to the nearest hundredth, that's that 6. So that 8 tells you where to round to. So your final amount in body after 30 hours will be 0.07 mLs. Is going to be my final answer. I'm just going to write that 30 a little bit nicer. There we go. Okay. So this one, not only did I use the full page, I kind of used another page as well. Again, I wrote kind of big, so that could explain some of that, but always make sure you have enough scratch paper if you need it. Okay. I also just want to point out how I got this answer. So I got this 0.07 by estimating or by rounding that k is equal to a negative 0.12. So I'm rounding throughout the process. Versus if I didn't round, if I kept k as that ln of 0.5 divided by 6, then my final amount would be slightly different. The final amount would still be calculated the same, where A is equal to 2.5 times my E, but now that K value is ln of 0.5 divided by 6 times your, what I said, 30. So it's the same calculation, but what the difference is that we're not rounding. Okay, so we're, instead of rounding that to a negative 0.12, we keep the exact answer. So I'm going to get that a is equal to a 0.078125. So when I'm rounding this to the nearest hundredth, this 8 tells me to round that up. So I'm going to have a is equal to a 0.08 mLs. So notice how rounding is going to change your answer. So this is using exact value, not rounding the k value. So using the exact value for k. So for your homework, just note that if you're using Newton, which is your homework, this is the answer that they're looking for. So if we were doing this in person and if I was grading your exams by hand, I would have accepted this 0.07 if you have rounded that k value ahead of time. But just know that since we're doing everything online on this online format, since we're using Newton for our homework and our exams, this is how I want you to round. Okay. So now I can go back to number 2. So for number 2, we're still using that formula that a is equal to my initial amount times e to the r times t power. Here they gave us the clue what a is already equal to. So my a has a value. So my a here is equal to 2 times my a naught, okay? And it says a virus takes 6 days to double its original population. So 6 days is going to be my time. Okay. And so if we have a is equal to a naught times e to the r times t, or sorry, not r, but it was k, right? Yeah. So I just want to make sure that we have the right formula here. So on the top of page 29, we're using k for our decay constant. So really, this should have been k. And you know, for our k, we're talking about that constant, okay? So now I can plug everything in. So we know that our a value is equal to 2 times the a naught since it was doubled. And our initial value, I don't know what that was, but I do know that my t value here was 6. Well, if that's the case, I still do the same where I divide by that initial amount, and whatever that initial amount is, it cancels. So now from here, I'm just going to ln both sides. So now the ln and e cancels. So I have my ln of 2 is equal to 6 times my k. And I'm going to divide everything by 6. So now my k value is equal to the ln of 2 divided by 6. And again, I am not going to round because of Newton. So I'm going to have now my k value is equal to ln of 2 divided by 6. And it's specifically asking me how long will it take to triple the population. So now, instead of it being doubled here, right, we're going to have that my final amount is going to be 3 a naught, since this is what we say when it triples. Since we know what happens when it doubles. So doubles and triples. And so let's see how we are going to fill this out. So I guess this all work was to find k. Now we're going to use k. So a is equal to my a naught times e to the k times t power. So since I am tripling, I have a 3 a naught is equal to my A naught times E. That K value that I found was the ln of 2 divided by 6. And we're trying to figure out the time, right? How long will it take? So T is unknown. I don't know how long it will take. That's what I'm trying to figure out. So what I can do here is divide out by the A naught on both sides. So I know that that can cancel. I'm left with 3 is equal to E to the ln of 2 divided by 6 times T. So now, like we've been doing before, I can ln both sides. So ln of 3 is equal to the ln of E to the ln of 2 divided by 6 times T. So that the ln's cancel. And I have natural log of 3 is equal to my natural log of 2 divided by 6 times T. So then from here, I can multiply by the reciprocal. So that would be 6 over the natural log of 2. So that here, I can have everything cancel. So I'm left with a T. So I have a 6 ln of 3 divided by my ln of 2. So I'm going to write that a little bit clearer over here. So 6 ln of 3 divided by my ln of 2 is equal to T. Okay? And that happened because I multiplied by the reciprocal and got T isolated. There, that makes it a little bit easier to read. So now I'm just going to plug this into my calculator. So I have a fraction 6 ln of 3 and my denominator is ln of 2. So I end up getting 9.509775 is equal to my T. And if I am rounding to the nearest tenth, oops, and that was a 5. So if I'm rounding to my nearest tenth, that's that 5 here. So this 0 tells us to leave it alone. So it would be 9.5. And this is in days. So in 9.5 days, it will triple. So for number 3, it says, researchers recorded that a certain bacteria population declined from 800,000 to 500,000 in 6 hours after the administration of medication. At this rate of decay, how many bacteria would there be at 24 hours? Round to the nearest whole number. So we have our final amount is equal to our initial amount times E to the K times T. Remember, that is going to be the same formula that we've been using. So here we have our time. So time is equal to 6. We also have our initial amount from 8,000. So my initial, so A naught is equal to 800,000. The final amount that we get is going to be our A. Our final amount is 500,000. Okay? So now we are going to find our K, which is going to be our growth constant. We don't know what that is. So I have A is equal to my A naught times E to the K times T. So my A value that I'm plugging in is going to be 500,000 is equal to the initial amount of 800,000 times E to the K, that's what I'm trying to figure out, and my time here is 6. So of course I can go ahead and divide by that 800,000. So if we think about it, we can just say, oh, well, that's just the same as 5 divided by 8 is equal to A to the 6K. And then I'm going to ln both sides. So we know that ln and e cancel each other out. So we are left with the ln of 5/8 is equal to 6k. So I can divide by 6 on each side so that the natural log of 5/8 being divided by 6 is equal to k. So now that I found that k value, I have to answer the second part of this. At this rate of decay, so that's the k, the decay that I have just found, I want to know what happens at this new time. So now this new time is going to be represented at t is equal to 24. And like I said before, the initial amount of 800,000 doesn't go anywhere. And we have our k value as a ln of 5 divided by 8 all over 6. So we want to know what is going to be your final amount. I don't know. That's what we're trying to figure out. So we have that A is equal to your initial amounts. That's the 800,000. E, and we have my k value, so ln of 5/8 being divided by 6. And the time here that we're plugging in is 24. So times 24. So let's go ahead and plug this into your calculator, and you're going to get a decimal approximation. And so with that decimal approximation, I got the value of 1222070.3125. So 122,070, and that much as my decimal. So since I'm rounding to the nearest whole number, this is my nearest whole number, so that 3 tells me to leave it alone. So I'm going to have 122,070 as the amount of bacteria after 24 hours. So, looking at example number 4, it says, well, even before it says anything, let's go ahead and write the formula down. A is equal to my initial amount times E to the K times T. So the half-life of radium-226 is about 1,590 years. How much of a 100 milligram sample will be left in 500 years? Write your answer rounded to the nearest tenth. So, okay, it tells us that our initial amount is here. And the initial amount is going to be A naught. So A naught is equal to 100 milligram sample, okay? And it tells us in about how many years. So that's going to be in the 500 years. So this is what eventually we want to happen as part B. Because in part A, which we're trying to figure out, we have to find the K value first. So we need to figure out the K value before we do anything else. So K is unknown. But once we figure out the K value, we're going to figure this out for what's going to happen in 500 years. But for now, let's focus on part A. So it tells us that the half-life is this many years. So I'm going to look at my T as the half-life. So this is describing the half-life. So let's think about this. If I have my initial of 100, and I'm thinking about my half-life, then we literally take half of 100. So you can either think about this as 0.5 times a 100, or half of 100 would be 50. Okay, so that's going to be your final amount if you're talking about the half-life, is going to be 50, okay? This is how much amount that is half. So in my part A, which is figuring out my k value, I have that my a value is equal to 50. My initial value is 100. It's times e to the k, which I'm trying to figure out, and that t for half-life is that 1590. So now I can divide by 100. So 50 divided by 100 gives me a 0.5, so that's pretty nice. So now I'm going to ln both sides. So the ln and e cancels. So I'm left with ln of 0.5 is equal to 1590 times my k value. So divide by 1590 on both sides, so that I have k is equal to the ln of 0.5 over 1590, which is great. Now I can focus on my part B, which is how much of a 100 milligram sample will be left in 500 years. So here we want to think about the 500 years. Well, that represents t for time. And don't forget, your initial value never changes. You started with 100, then you still start with 100. What's different now is now I know my k value to be my ln of 0.5 over my 1590. So what you're trying to figure out is going to be, well, how much of your final amount will you have at the end? That's your unknown. So now you have A is equal to your initial amount times E to your k value times your t for time, which is 500. So now I just plug all of this into my calculator. And on my calculator, I got 80.414893132. And it specifically said to round this to the nearest tenth. So that would be my nearest tenth. So I'm going to have my end amount is 80.4. And it'll be my milligrams. Okay. And that is the end of this section and this chapter. If you guys have any questions, please feel free to email me, the Math Success Center, or our tutor. Thank you.